Hello students, this is Srinivas sir and you are watching Sri9 Teaching YouTube channel. Now in this video, now onwards I am going to give you the revision of physical science for SSC students for the year 2022 final examinations. Now here, for the long time you have been asking for giving important questions as well as the concepts in physical science as well as in mathematics. Now here in this video you are going to get the revision of physical science for the year 2022 in every chapter along with the concepts and important questions. Okay, now please continue watching till the end so that you can get good marks in the final examinations as well as in your pre-final exams. Okay, so here I will give you the concepts, the revision of the concepts and the important questions in physical science chapter wise. Okay, so daily or within 2 days I will upload one video like that. Okay, right, so please continue watching. Now here in this video, now I will explain the concepts as well as the important questions in the first chapter. Okay, right, now let us go to the first chapter, that is reflection of light at curved surfaces. Okay, dear students, now let us focus once again on the chapters, that is the syllabus for the year. Which chapters are there for this year, that is 2022 examinations. Let us see the index. Now first chapter is reflection of light at curved surfaces, and the second chapter is chemical equations, third is acids, bases and salts, fourth refraction of light at curved surfaces, fifth human eye and colorful world. In this one up to defects of vision only. Now sixth, the structure of atom, seventh classification of elements, the periodic table, eighth, that is eighth chapter is not there, that is ninth electric current, and the 11th principles of metallurgy. Now as you know, the chapters 8th, 10th, 12th are deleted, right? Yes, please see on the screen. The first chapter, reflection of light at curved surfaces. Now the main concept, see the first one. Now here curved surfaces are nothing but the spherical mirrors. Now we know that spherical mirrors are of two types. Okay, what are they? One is concave mirrors and the second one is convex mirrors. Now the third point, identifying the pole, center of curvature and focus of a concave mirror. Now here you see on the screen here, the picture shows the concave mirror and the parts. So here let us explain. Now this is concave mirror, right? Now the center point is called pole. The center point of the mirror is called pole, and here you can see a line is drawn. A line is drawn where we can see the pole, and F is nothing but focus, and C is called center of curvature. These are the main parts of the concave mirror, right? So here you see in case of concave mirror we see the focus and center of curvature on the right hand side, but whereas in the convex mirror, see the figure here, identifying the pole, center of curvature and focus of a convex mirror. You can see the convex mirror here. On the convex mirror the coating is on the left side, but the bulged side is on the right side, right? Now you see we will draw the line from the right to left side, hence the center of the mirror is pole, and inside F is focus and C is the center of curvature. Okay, right, the next point, you see the point of intersection of all normals drawn from the point of incidence to mirror is known as center of curvature. Now this is the definition for center of curvature. So the center of curvature can be drawn using a ray diagram. Now question may be asked, how do you locate or how do you show the center of curvature for a concave mirror? Means you can write this point. So that's why I said along with the important concepts I will explain the important questions, right? Now you can see on the screen, you see the concave mirror, and the blue color line is nothing but, yes, this is So this is this principal axis here as it is shown here, and you can see the incident rays are coming from the right hand side to the left hand side, and they are falling on the concave mirror, and they are here the points where the incident lines are focused. From there the red dotted lines are nothing but normals. They are not reflected rays, they are the normals. You can see in the figure the red color, the red dotted lines, where they are intersecting, where they are meeting at a point on the principal axis, which is called center of curvature, and the dotted lines are nothing but normals. Okay, yes, the normal is nothing but the line from the any point on the surface of the mirror to the center of curvature is called normal. Hence all the normals nothing but they are radii of curvature is actually. So all the normals meet at the point on the principal axis, that is at C, which is called center of curvature. So how can you say here? So here, how do you draw the center of, how do you locate the center of curvature means, here we can say that the incident rays which are traveling parallel to the principal axis and they meet the concave mirror, from the points we can draw the normals, and they meet at a point on the principal axis. So the point is called center of curvature, right? So the center of curvature can be drawn using a diagram like this. Next you see the focal length of mirror is equal to the half of the radius of curvature. Now what is focal length actually? Let us see the focal length, right? Now here the focal length is nothing but the distance from the pole to the focus. Now what is focus? Now here I will show the focus on the screen. See, I am drawing. Now this is the concave mirror, right? Okay, now this is the principal axis. Now let us draw one line here. Yes, so these are the incident rays. After falling on the concave mirror, they get reflected and they meet at a point. Yes, after reflection they meet at a point which is called focus. Got it? And here this is pole. Okay, now you see the left hand side. Now the distance from the pole to focus is called focal length, and this is designated by small f. And here the distance from the P to F is also equal to the distance from F to C. So this is also focus. So hence the distance from P to C is equal to 2 of or 2 in 2 focal lengths, isn't it? So now what is actual distance from P to C? This is radius of curvature. Hence here we say R is equal to 2F. Got it? Yes, because the radius of curvature is equal to double the focal length. Got it? Right. So because the length from P to F is focal length and F to C is also equal to the focal length. Hence we consider 2 of focal lengths. So hence here radius of curvature is equal to 2 into F, that is 2 focal length. And suppose if you want focal length, then what we do? F is half of the radius of curvature. Isn't it? Because one focal length is half of the radius of curvature. So from here to here and here to here. Hence we say radius of curvature is equal to 2 into focal length, or F is equal to R by 2. R by 2 is nothing but one focal length is equal to half of the radius of curvature. Right? Yes. Hence we say if focal length small f, radius of curvature R, then focal length of the mirror small f is equals to R by 2. Okay. In other way, radius of curvature is equal to 2F. Yes, I will write on the screen here. Yes, we know that R is equal to 2F. Okay, or F is equal to R by 2. Got it? Yeah, remember that. Yeah, you see on the screen once again, if focal length small f, radius of curvature R, then focal length of the mirror small f is equals to R by 2. Now next point, you see the second point, if the radius of curvature of the mirror is 30 centimeters and finds the focal length of the mirror. Okay, once you concentrate on this answer, see the answer radius of curvature of a mirror is given 30 centimeters. We know focal length of the mirror is equals to r by 2. So r is 30 centimeters. Hence r by 2 is nothing but 30 by 2. So r by 2 is equals to 30 by 2, and here 2 ones are 2, 2 15s are 30. Hence, so it becomes 15 centimeters. Hence, focal length of the mirror is 15. Yes, here the experiment. Here you see the material required to find the nature of the image formed when an object is placed at different places on the principal axis of a concave mirror and experimental procedure. So the question may come like this. That is, what material is required to find the nature of the image formed when an object is placed at different places on the principal axis of a concave mirror, and write the procedure. Such question may come. Yes, the material required for the experiment are concave mirror of known focal length, V stand, screen, object or candle, meter scale, even matchbox also. Now see the precautions. First, adjust the screen without disturbing the incident and reflected rays. So you have to take care that whether the rays of the candle are falling on the mirror, and also they should get reflected and which can be caught on the screen. So that will be image. Okay, that is the first precaution. Now second, size of the object adjusted must be as per the height of the lens placed on V stand. Yes, so to see the image clearly, we have to take care that the image should form on the screen such that the object should be adjusted so that the object, which is nothing but candle, its light should fall in the mirror and should we get the image on the screen, right? So these two are the precautions. Now let us see the procedure. Place the mirror on the V stand. First, place the object on the principal axis at different places from the mirror beyond C. That is one beyond C means we will come from the right side to the left side. So C beyond we keep the object, and at the second case we keep the object at C, and next between C and F, and at F between F and P. So these are the positions where we place the candle, nothing but object, and we will observe the images on the screen by adjusting the lens so that we get the sharp image, right? Now see the second point. Adjust the object to get sharp image on the screen. Measure the object and image distances. Tabulate the values in the following table. Observe the mention the images are inverted or erected. Inverted means upside down and erected means straight upward. Okay, now this is the table, as you know, in which we will when we conduct experiment we write the readings in this table. That is serial number, object distance, image distance, whether the image is magnified or diminished, and it is whether erected or inverted image. So this is the table we have to draw while writing the experiment procedure, right? So here this is the answer for which the question we asked, like what are the material required, precautions and procedure. In such question we write this answer. Okay, so directly you can learn and write. It is easy. Let us discuss the spherical mirrors and their respective ray diagrams. Okay, now here first to draw the ray diagrams, what are needed? The rules are needed, right? So now see rules to draw the ray diagrams of formation of image by spherical mirrors, both for concave and convex mirrors. Now the first rule, you see the first rule as you have already learned, but once again we are discussing. Now first rule, all the rays that are parallel to the principal axis gets reflected such that they pass through the focal point of the mirror. So I will show you once. See on the left side concave mirror. Now the black color thick line is principal axis on which P is the pole, F is focus, C is the center of curvature. Now the red line, so the red line which is coming from the right side is nothing but incident ray, and it is falling on the concave mirror and it is reflected, right? This is reflected ray and it is going through focus. Okay, and this incident ray is traveling parallel to the principal axis. Yes, it is traveling principal axis, parallel to the principal axis, and it is coming like this and traveling through the focus. It is traveling through the focus, yes, in the case of concave mirror. Whereas in the convex mirror, you see the black line is nothing but principal axis, P is the pole, F is focus, C is the center of curvature, and this red line is incident light which is coming traveling parallel to the principal axis and falling on the mirror, that is convex mirror, and it is appearing going like this. It is diverged, and it looks like as it is coming from the focus, hence it is a focus. Okay, so in the both cases the ray travels through the focus. Which ray? The ray which is coming from the source and traveling parallel to the principal axis. After reflecting, it travels through the focus. Okay, that is the first rule. Now let us go to the second rule. You see, the second rule, all the rays that passes through the focal point of the mirror will travel parallel to the principal axis after reflection. In the first case, we have seen that if the ray travel parallel to the principal axis, it gets reflected, passes through the focus, isn't it? And the inverse of that, if the ray travel through the focus, what happens? It travel parallel to the principal axis. If the ray traveling parallel to the principal axis, it goes to the focus, and the ray, if traveling through the focus after reflection, it travels parallel to the principal axis. You can see the picture on the left side. See, as you know, the black line is principal axis, PFC, you know the positions, and the red line, you see. So this is the incident ray which is traveling through focus. So this is traveling through focus after reflection. What is happening? It is traveling parallel to the principal axis. In the case of convex mirror, you can see this ray is traveling through the focus, and after reflection, it is traveling parallel to the principal axis, right? So this is the second rule. Now the third rule. You see the third rule, a ray coming from the tip of the object passing through the center of curvature. Previously it was passing through F, now it is passing through C, that is center of curvature, to meet the mirror after refraction. It is not refraction, it should be reflection. Here it is, so it should be reflection. After reflection, what happens? The ray retraces its path. It means, see, the ray is traveling like this, and it is passing through center, and it is coming to the mirror. After reflection, it travels along the same path. You see, so this is the incident ray, and it is reflecting along the same path. Now here also, in the case of convex mirror, the ray is coming like this, and it is traveling from the mirror along the same path backwards. So if the ray travels through the center of curvature, after reflection, it travels along the same path in backward direction. Okay, so this is the third rule. Now let us see the fourth rule here. Now the fourth rule, this is the fourth rule. See on the screen here. So here the fourth rule, what is that? A ray coming from the object passing through the principal axis to meet the mirror, it will get reflected along the principal axis. Now you can see, so this is the principal axis, and the ray coming like this along the principal axis. After that, it is traveling along the principal axis backward direction, isn't it? Even it is same in the case of convex mirror. Here the ray is coming in this direction and traveling again back along the principal axis. Okay, so these are the four rules which you have to remember to draw the ray diagrams for the images formed in the case of concave mirrors or in the case of convex mirrors. Okay, now these are the important concepts which we are discussing. Now you see, yes, the ray diagrams. So simply you can see, in short I will explain here. First, concave mirror, characteristics of the image formed when the object is placed beyond C. The first case. See the first case of ray diagrams, concave mirror. Here characteristics of the image formed when object is placed beyond C. Now here you can see on the screen, this is the concave mirror, and here this is the object. Okay, two rays are coming. One is parallel to the principal axis, that is ray coming from the object along this direction, and after getting reflection, it is passing through the focus, right? And another is a ray which is coming from the tip of the object, and it is traveling through the focus. After reflection, it is traveling parallel to the principal axis, and they meet at this point. Here they meet at this point. So here this is the image, and this is object. This is O, and this is I. See, after observing the object and image, so here observing the image, the characteristics, you see how it is. The image is inverted, that is upside down, and it is, so the second point is, when the object is beyond C, image forms where? Between F and C. The first point is that the image forms between F and C, and the image is inverted, that is correct, and it is diminished. It is not enlarged, it is diminished, nothing but smaller than the object, and it is real image because it caught on the screen and it is formed between F and C. So this is the first case. Be careful. It is also there in your textbooks. You can better draw as many times. Okay, you can write. You see concave mirror characteristic of the image formed when the object is placed at C. See, this is one ray and this is another ray which are coming to the principal to the concave mirror. After that it reflected back, and this ray also reflected back. They meet at here, they meet it there where object is there. Hence, so object and image are formed at the same place, that is at center of curvature only, right? Now the characteristics, you see, it is inverted. Yes, at all it is inverted and equal to the size of the object. It is real image and the image is formed at C, right? So this is the second case where object is placed at C. Now let us see the next case, that is third case. Concave mirror characteristics of the image formed when the object is placed between F and C. Here you can see the screen, the blue color object is placed between F and C. So in the first case, when object is placed beyond C, the image is formed between F and C. And now the object is placed between F and C, and where image forms? Yes, beyond C. So hence here the image is formed on the beyond the C. You can see the ray diagram on the screen. Okay, so object is between F and C and the image is beyond C, right? And the characteristics, obviously the image is inverted and it is not diminished, it is enlarged. So here this is wrong, it is enlarged. Okay, so the image is enlarged and it is a real image formed beyond C. So the third case is opposite to the first case, right? Now let us see the fourth case. Concave mirror characteristics of the image formed when the object is at F, at focus. You can see, so this is very important case here. So here at the tip, the ray is going upward and is coming back as it is coming from the center of curvature. Now the two rays are traveling parallel to each other, so hence they will not meet, hence we cannot say where image forms. Hence here you see the characteristics of the image. The two reflected rays are parallel to each other, they do not intersect if extended either sides. Third point, so we cannot say whether they are real or virtual image, but we can say that image is enlarged and formed at infinite. And at this point I will say one important point, what is real image and what is virtual image. Here the real image is nothing but which can be caught on the screen. We can see the image on the screen, that is called, such image is called real image. And the image which cannot be caught on the screen is called virtual image, because we cannot see the image on the screen but we can see the image inside the mirror. Okay, so such image is called virtual, but the image which is caught on the screen is called real. And the second point, real images are formed by concave mirror, where virtual images are formed by convex mirror. In one case of the concave mirror, at the end, now we will discuss, in one case only virtual images form in concave mirror, right? Now, so that is we are now discussing. Concave mirror characteristics of the image formed when the object is placed between P and F. Yes, you see here the object is placed between P and F. See here, this is P and this is F. Now object is placed at between P and F, and the image is formed inside the mirror which is erected. How the image is formed? You can see from the tip the rays traveled parallel, then it is reflected and passed through focus. Another ray, this ray here, it is coming from the tip of the object and met at the concave mirror and reflected back through it, which is traveling through the center of curvature. And the two rays here, not they are meeting front side, but if they are extended backwards, they mate it here, and here the tip of the object is formed in the form of image. So hence here we say the image is formed inside the mirror, okay, which is erected, which is enlarged, virtual image formed, okay, and it is formed inside the mirror. So this is very important case in the case of concave mirror, that is fifth case. Now you see, here we see on the screen characteristics of the image formed by a concave, not concave, it is convex mirror. When an object is placed in front of the convex, not concave, it is also convex. So in front of the convex mirror. See here on the screen, now this is the object and here this is a convex mirror. As object is placed in front of the convex mirror, you see a ray is coming from the tip of the object, and after that it reflected back along the same direction, and it is traveling through center of curvature inside. Okay, and another blue color ray, it is traveling as it is appearing for passing through the focus, and it is get reflected parallel to the principal axis. Okay, and here if you extend backward, okay, see this ray is traveling through the center of curvature, and this ray is reflected back and traveled parallel to the principal axis, and these two rays, this ray and this ray, if they are extended and they met here, and their image is formed inside the convex mirror. So wherever you place the object in front of the convex mirror, the image always forms between F and P here. So wherever you can keep object here in front of the convex, remember it is convex mirror, always the image forms inside, which is first it is erected, diminished, small virtual image. Virtual is nothing but which cannot be caught on the screen but can be seen inside the mirror. So as such property means wherever the object is placed, always the image will be small. Hence this property is used in the form of rear view mirrors for the vehicles, so that the driver can see the objects which are coming from the back side, though they are big but they appear small inside the mirror. So and by seeing that image inside the mirror, he can think, okay, which objects are coming from the back side, so the driver can drive safely and easily, right? So because of this property only, convex mirrors are used as rear view mirrors. Very important use of the convex mirror, right? Now one important point in the first chapter, that is mirror formula. Here you see object distance is equals to u, image distance is equals to v, and focal length is taken as f, and the mirror formula is 1 by f is equal to 1 by v plus 1 by u. Now this is the mirror formula, and here u is the object distance, v is the image distance, okay, and f is the focal length, small f is the focal length. Now here while doing the problems, we take f is negative, u is also negative, and v is also negative, but v depends on the values of u and f, remember. Okay, yes. Now here sign convention for spherical mirrors, very important. So here first point, now here the first point, sign convention for spherical mirrors is that, first point, all the distances are measured from the pole of the mirrors. That is the first point, all the distances are measured from the pole of the mirrors. And second point is that, see here, all distances should be measured from the pole. The distance is measured in the direction of the incident light to be taken positive, and those measured in the direction of opposite to the incident light are to be taken as negative. It means that, now suppose this is concave mirror and this is the principal axis, and this is the object. Now here this is the incident light. Okay, now here this is the pole P. Now here we have to measure the distances from the pole to these directions. Now incident light is coming in this direction, left side, and we are measuring towards right side. Then the distance of the object u is taken as negative. Okay, now this is the direction we measure. Actually this is the direction we measure, towards right we measure. If the light is coming towards left, then the distance from the object is taken as negative. Okay, right. So you remember that always we measure the distances from left to right, and if the incident light is coming from right to left, then such distances are taken as negative. And if we measure, suppose the image is formed here, okay, inside the mirror, and we are measuring from this side, and suppose the the rays are extended towards left side, so we are measuring towards left, and the ray is also traveled towards back, that is left side. So the distance and the traveling of ray are on the same direction, then in such cases we take the distance as positive. Hence the second point, the distances measured in the direction of incident light to be taken positive, and those measured in the direction of opposite to incident light are taken to be negative. Now next, height of the object. So height of the object HO, height of the image HI are positive if measured upwards. So suppose this is the principal axis and this is the mirror and this is upward direction, hence we take plus. And if it is direction negative, if it is downwards, whether it is object or image, remember. Okay. Now see, what is magnification? Magnification of spherical mirrors. A magnification shows the changes in the size of the image. A magnification shows the changes in the length of the image also. Now formula, magnification is the relation between the object distance and the image distance. Not only that, it is a relation between height of the object as well as height of the image. See, the formula, magnification M is equals to minus image distance V by object distance U, which is equals to height of the image HI by height of the object HO. Now let us see the final uses of the concave mirrors. First, dentists use the mirror to check the teeth. Second, in the microscopes. Third, in the security systems. Fourth, in the preparation of solar cooker. That is these are the uses of concave mirrors. Now next, uses of the convex mirrors. These mirrors are used as rear view mirrors in vehicles. Second, at junctions of the roads. Third, in the shopping malls. Fourth, at curved roads. Okay. Now the important question, what would happen if the concave mirrors weren't discovered? What would happen if the concave mirrors were not discovered? Very, very important question. And the answer is, if the concave mirrors were not discovered, the dentist can't check the teeth, the solar cooker couldn't be in use, and the car headlights would be different. Okay, so this is a very important question for this. What would happen if the concave mirrors were not discovered? The answer is, if the concave mirrors were not discovered, the dentist can't check the teeth, the solar cooker could not be in use, and the car headlights would be different. Now this is the important question, that is differences between real image and virtual image. Very, very important. On the left side, real image, and the right side, virtual image. Left side, first point, it is an inverted image. Right side, it is a erected image. Left side, it can be caught on the screen, and virtual image, it cannot be caught on the screen. Third, it can be formed by using concave mirrors but not with the convex mirrors, sorry. It can be formed by both concave and convex mirrors. Last point, it is formed by the reflected rays. And last point, right side, it can be formed by extending the lines of the reflected rays. Here is the one problem question. Sum it is. Now see the question. An object is placed at 20 centimeter distance from the pole of concave mirror, and the image formed at 4 centimeters from the pole. Find the focal length of the mirror. Now see, an object is placed at 12 centimeters. Now we are discussing the answer. Object distance U is equals to 12 centimeters. Now image distance V is given 4 centimeters. Focal length F is equal to question mark. Now what is mirror formula? 1 by F is equals to 1 by V plus 1 by U. Now here care should be taken while substituting the values. Here it is in the case of concave mirror. Hence all the values are taken as negative. Hence we have to find F. Now 12 will be negative and 4 also will be negative. In this formula, 1 by F is equal to 1 by minus 4 plus 1 by minus 12. Now taking LCM, here I will write on the screen. So 1 by F is equals to 1 by minus 4 minus 1 by 12 because both are negative. Now is equals to LCM, you take 12. Now 4 goes 3 times, hence it will be minus 3 minus 12 goes 1 time, hence 1 ones are 1. Now it will be equal to minus 4 by 12. Okay, so 4 by 12 means 4 ones are and 4 threes are. Hence 1 by f is equals to minus 1 by 3. Okay, the same thing here we got here. 1 by f is equal to minus 1 by 3. Hence if it is written in the form of reciprocals, f is equals to minus 3. Got it? Now let us see the important questions. You can find the answers in your notes or question banks, whatever the material you have. Very important questions. Now very short answer questions. First, 1 or 2 marks. First question, what would happen if spherical mirrors were not invented or not discovered? We already discussed the answer in the previous section, in the above section. Okay, now second, write the uses of spherical mirrors. This also answer is there. Third, what happens if concave mirrors are used as rear view mirrors of vehicles? Here concentrate, concave mirrors asked. Generally convex mirrors are used as rear view mirrors. So hence what happens if concave mirrors are used as rear view mirrors in the vehicles means the answer is, in concave mirrors the image forms at different places for the different positions of the object in front of the concave mirror. At once the image will be small, at once the image will be big, and at once it will be inverted, and at the other it will be erected. Hence the driver cannot see the image clearly in the concave mirror, hence accidents may happen, hence it is not suggestible. So that's why concave mirrors are not used as rear view mirrors, right? Now let us see the short answer questions. Fourth one, an object is placed in front of the concave mirror whose magnification is plus 1.75. What does it mean? Very important. Here plus 1.75, plus means upside and it is more than 1. Hence the image is enlarged, or the size of the image is more than the object, and plus is given, hence it is erected. That is the answer. Now fifth, is the focal length of mirrors are same in all media? Yes, the focal length of mirrors may not be same in all media, like in air, water or in oil, because water and oil also the substances which through which light travels, and the speed may change, hence we cannot see the reflected rays same in all media. Yes. Now sixth, very important question, that is fifth one. Now sixth, what changes may happen to the images formed by a concave mirror when an object is moving from beyond C towards pole of the mirror on its principal axis? It is in concave mirror, we have seen. So when we move towards the mirror from the pole, means from the right side, if we move towards left side the object, and the image goes from the left to right, and the size of the image, first it was small, and when we go towards right the image size increases, but the object size may be same, hence the image size increases when object moves from C to pole. Okay, and at the end in all cases we get inverted image, but at the end we will get virtual image inside the mirror. Yes, yeah. Seventh question, draw ray diagrams when an object is placed 8 centimeters from the pole of the convex mirror. Yes, convex mirror, wherever the object is placed in front of the convex mirror, always the image forms inside the mirror. One diagram only is there, whatever the distance is given. Concentrate. Eighth question, write the differences between the images formed by a concave mirror when an object is placed beyond C and object is placed in front of the convex mirror. So here what happens, beyond C, in case of concave mirror, if the image is placed beyond C, the image will be small, and even the in front of the convex mirror the image also small. Okay, yeah. Now long answer type questions, you can read by pausing the screen. You can read and you can get the answers. If you not get, means in the next coming video I will do the answers. Okay, please concentrate and read yourself. These are important questions. And here 12th one, very important question, 12th one, this time it will come definitely. Observe the following information and answer the following questions. So here the object, image, magnification are given, and the questions you see, which of the object forms virtual image? So virtual image here, in both the cases virtual images are erected. Be careful, virtual images are erected. So in which of the object forms virtual image means object A. Okay, because remember the clear thing is virtual images are erected. Okay, now second question, which object is placed at radius of curvature? So same size, radius of curvature means here radius of curvature is nothing but at C, isn't it? P to C, radius of curvature. Hence when object is placed at C, image also forms at C, hence equal to that of object size. That is, which object is placed at radius of curvature means definitely it is C, object C. Third question, which object forms erect image? Definitely the object A, hence the answer is object A. Fourth, if the height of the object is C is 3 centimeters, then what is the height of the image? We know that when object is placed at C, we'll get the image of same size of that of object. Hence, the height of the object is also 3 centimeters. Yes, with this, the questions are over, and here you can see the multiple choice questions. Now you see the multiple choice questions. First, focal length of concave mirror is 30 centimeters. Object distance is 60 centimeters. Then the image distance is. Now here the focal length is nothing but P to F is 30, and the radius of curvature will be 30 plus 30, 60. It means that object is placed at 60. Definitely image is also forms at 60. So hence the image distance is minus 60. Be careful, in the case of concave mirror all the values are negative. Hence the answer is D. Answer is D, minus 60 centimeters. Second question, the focal length of the concave mirror if the radius of curvature is 10 centimeters. Yes, F is equals to R by 2, hence 10 by 2 is 5 centimeters. Answer is D for the second question. Third, the formula of magnification of the image formed by the object using concave mirror is M is equals to minus V by U. Then U indicates, definitely U is nothing but the object distance. So object distance from the pole. B is the answer for third question. Now fourth question, which one is not possible for the magnification by a concave mirror? The answer is D, M is equals to minus 1. Now fifth one, virtual image formed due to. The answer for the sixth question is answer B, F is equals to V plus U by UV. Now the seventh question, the rays are incident on the concave mirror parallel and converging at 20 centimeters on the principal axis. Then the radius of curvature of the mirror is. So here the converging means focal length is given 20 centimeters. Focal length is given means, okay, radius of curvature R is equals to 2F, that is 2 into 20, 40 centimeters. Hence seventh question answer is B, 40 centimeters. Now the eighth question, which of the following is used in the solar cooker? Obviously concave mirror. So answer is C. And the ninth question, which of the following always gives virtual image? It is nothing but a convex mirror. Okay, so with this one, now the revision of the first chapter, that is reflection of light at curved surfaces, is over. So everything I explained, and even if you get any doubt you can ask me in the comment section. I hope everybody, for everybody, each student, this video is very useful. So if you feel that this is useful to you, please like my video and share it to your friends, and subscribe my channel for the next coming videos which are very, very important to you for the final examinations as well as your pre-finals. Okay, so thank you for watching.